Hi, welcome to this example. We're looking at a binomial probability, binomial distribution example. So during the 2013 regular NBA season, DeAndre Jordan of the LA Clippers had the highest field goal completion rate in the league. DeAndre scored 61.3% of his shots. Suppose you choose a random sample of 80 shots made by DeAndre during the 2013 season. Let X be the number of shots that scored points. All right, so basically that's your success. All right, so you have your is it binomial? So yeah, there are two choices, and those are like successes that he took a shot and he scored. So success is that he scored. All right. And now independence. Right, so are the probability of one shot to the next independent? You could claim that they are because it's this person, right? Now, because you are looking at a random sample of his throws, they should be independent from each other. If you're just taking one game, they might not be, because he might be feeling great, or he might be feeling not so great, or he might kind of be feeling under pressure. But because your selection of his shots is random, and basically it's like he's doing the shooting, you're kind of looking at an average picture of his success, right? So that's why you're saying they're independent. And the probability of the success of a shot is 61.3%. This is 0.613. Okay, so that's the probability of success on each shot he takes. All right. So you're looking at 80 of his shots, right, historically, and X is the number of shots that scored points. So if you take in that sample, X could take the values anywhere from 0 up to 80. You could have scored none of these or all of them, or somewhere in between, okay? So you're finding the probabilities based on that. So part A, what's the probability distribution of X? It's going to be binomial distribution because two choices independent, all right? And then you have your probability of success for a single shot is 0.613. And the sample size is 80. Okay, so that's kind of the information that you need to give there, right? So using the formula, calculate mean standard deviation. So the mean is NP, and the standard deviation is the square root of NPQ. So 80 times 0.613. Just plug that in the calculator. I get 49.04. I'm going to say approximately 49 because we're talking about how many shots were successful. And the standard deviation is going to be that number, N times P. So 80 times 0.613 times 1 minus this. Okay, so let me just write that. So 80 times 0.613 and then 1 minus 0.613. Right, so times 1 minus 0.613 times 0.613 times 1 minus 0.613, and then take the square root of that. So we get 0.62. Alright, that wasn't it. I checked in my calculator, I just mistyped stuff. It was like 4.4. Alright, let's look at C. Find the probability that DeAndre scored with 60 of these shots. So we're finding the probability that X equals 60 exactly. And then D says find the probability that DeAndre scored with more than 50 of these shots. So the probability X is bigger than 50. And this we do with StatCrunch or calculator. So let's go here. All right, you want to go to Stat Calculators Binomial. Then you want to enter your n, which is 80, and your p, which is 0.613. And the first probability one, we wanted x equals 60 exactly, 0.0036. And the next probability is that x is bigger than 50. So I go here and change it to bigger than 50, 0.3718. Alright, that's it. Those are the probabilities with the help of StatCrunch.